All right, so now that we know all of the methods of solving systems of equations, let's talk application problems. Let me quick adjust. All right, there we go. So it's very similar to the application problems or the word problems that we worked with back in chapter 6 when we were writing equations and graphing, and even chapter 5 back when we were working with function rules and stuff. So it's very similar where we have to define our variables, write our equation, and then in this case we have to solve. And we can solve using any method, and and of course we're going to walk through and I'll show you what that means. So remember, with a system, that means two equations, okay? And they each have two variables. So 9 times out of 10, you're going to use x and y. If you want to change it up, you can. No big deal. It doesn't matter what your variables are. So let's go through and read the problem. So number one, when you are working with application problems or word problems, first thing I want you to do is read the problem. I don't want you to circle. I don't want you to highlight. I don't want you to underline. I just want you to read the problem and get a gist of what the problem is saying. Okay, so first let's read it. Your school is planning to bring 193 people to a competition at another school. There are 8 drivers available and 2 types of vehicles, school buses and minivans. The school buses seat 51 people each, and the minivans seat 8 people each. How many buses and minivans will be needed? Okay, so let's go back and reread, and now let's highlight, circle, underline, whatever works for you, the important information, and kind of pick out the different types of things and what we're looking for, okay? Your school is planning to bring 193 people to a competition at another school. That's important, right? That tells us how many people need to be there. So 193. Okay. At another school, there are 8 drivers available and 2 types of vehicles. We've got school buses and minivans, so there are 2 different vehicles. The school buses, 51 people each, and minivans are 8 people each. So minivans, 8 people each, school buses, 51. Okay, and notice how I have people highlighted in the same color as the other people numbers. So I have the topics staying together, and we have 8 drivers. So here we go, 2 types of vehicles. So 2 vehicles, 8 drivers. That topic goes together as well. Okay, so now how many buses and minivans will be needed? So 2 variables. Guys, what's the question? The question is how many buses and minivans will be needed. So that's what your variables are going to be. Your variables always relate back to your question. So buses, minivans. Let's make X buses, Y minivans. So number of buses, number of minivans. So remember, your variables are things that you don't know. We don't know how many buses and we don't know how many minivans, okay? And that's what the question's asking, so that's what our variable is. Write your equation. So we're going to have 2 equations. Our first equation. Let's work with the yellow, and then we'll work with the orange. So our yellow information, 193 people, is that what is that? What is that representing? Is that representing the total? Is that representing something else? It's representing the total. So I'm going to write total. Okay. And where does total go in your equation? Where do you think it goes? You have your equation, right? And it's going to be x something something, y something equals something something. Where's the total go? It's going to go after your equal sign. So you have 193 after your equal sign. I'm looking for other yellow. School buses seat 51 people each. So school buses is x, so 51 x plus 8 people each for the minivans, so plus 8 y. Okay, equals 193. All I'm going to do is mark a little yellow there, so that way you know that's my yellow information. Now I need to work with my orange information. I've got 8 drivers, 2 types of vehicles. 8 is our total. So again, this is another total. So it's the total number of drivers. 8, right? And we have to do something with x and y here too. Well, X is the number of buses. So the number of buses plus the number of minivans equals our total number of drivers or our total number of vehicles, because you can only have one driver per vehicle, or each vehicle needs one driver. So it's going to be X plus Y equals 8. Okay, and again, this is going to be our orange. Okay, I have my two equations. Pick any method to solve. Okay, graphing. Does it make sense to graph these two? Absolutely not. They're not in slope-intercept form, right? We're dealing with really big numbers, so graphing is really not going to be easy. What about substitution? We could do substitution. Sure. We could get a variable by itself and then substitute. But do we have a variable by itself as it is? No. What about elimination? Would it be easy to try and get a variable to be eliminated from our systems? Sure. I think the easiest method is going to be elimination. But guys, if you want to use a different method, please feel free. You should get the same exact answer. So I'm going to rewrite. 51x plus 8y 193. I'm going to go ahead and rewrite my equations. And now I'm going to complete my elimination process. I want to cancel out my y's. You can cancel out your x's. Doesn't matter. Okay? I'm choosing my y's. So I have 1y and 8y. So I need this to be negative 8. So meaning I need to multiply this equation by negative 8. So I'm going to get negative 8x minus 8y equals negative 64. And I'm just going to rewrite this guy. So I have 51x plus 8y equals 193. Okay, add them up. These are going to cancel. So I get 51x minus 8x. So 51 minus 8, 43. X equals 193 plus negative 64. 129. Divide. X equals 3. Okay, so x equals 3. Now I need to plug that into one of my original equations and solve for y. So I'm going to plug it into the second equation. So I get 3 plus y equals 8 minus 3 on both sides. Y equals 5. Now, the only thing that's different from the way we solved systems before is that we're not writing our answer as a coordinate pair. We want to define our answer in terms of the problem. So we want to use our keywords and our variable definitions to write our solution. So x equals 3, what does that mean? X equals 3 means we have 3 buses. Y equals 5 means we have 5 minivans. That's going to be your answer, because that answers the question. How many buses and minivans will be needed? 3 buses, 5 minivans.